next problem is integral a to b dx by x minus a power p converges p less than 1 and diverges p greater than 1. Obviously here integrand is 1 by x minus a power p is discontinuous at x equal to a. That is 1 by x minus a power p is unbounded at x equal to a. Here 1 by x minus a power p is discontinuous at lower limit x equal to a. So we need to integrate. This is an improper integral. We need to integrate improper integral by the definition of improper integral second kind. Integral a to b dx by x minus a power p equal to limit epsilon tends to 0. Integral a plus epsilon a plus epsilon to b 1 by x minus a power p dx. Here a plus epsilon and b are finite upper limit and lower limits respectively. So you can integrate proper integral. So limit epsilon tends to 0, x minus a minus p plus 1 divided by minus p plus 1 and a plus epsilon and b. That is equal to limit epsilon tends to 0. You can give upper limit and lower limit b minus a power 1 minus p minus a plus epsilon minus a power 1 minus p. We will take outside this 1 minus p, 1 by 1 minus p. Okay. Limit epsilon tends to 0, 1 by 1 minus p, b minus a power 1 minus p minus epsilon power 1 minus p. We will get limit epsilon tends to 0, 1 by 1 minus p into b minus a power 1 minus p minus epsilon power 1 minus p. If p not equal to 1. So first we can, so here epsilon power 1 minus p. So first we can analyze what is the limit value of epsilon power 1 minus p in the case of p less than 1 and p greater than 1. So in the case of p less than 1, limit epsilon tends to 0. Epsilon is a small value. P less than 1, 1 minus p is a positive value. P less than 1, so 1 minus p is a positive value. So that limit will become 0. So if p less than 1, this limit value is 0. Next is p greater than 1. Next is p greater than 1. In the case of p greater than 1, epsilon power 1 minus p, epsilon power 1 minus p, 1 minus p will become negative. So 1 by epsilon power some power. So limit epsilon tends to 0, that will become infinity. So limit epsilon tends to 0, epsilon power 1 minus p is infinity. P in the case of p greater than 1. That is p less than 1, epsilon power 1 minus p is positive. So epsilon power some positive number. So we will take limit, that will become 0. P will become p greater than 1, 1 minus p will become negative. So epsilon power some negative, that can be written as 1 by epsilon power, limit epsilon tends to 0, 1 by epsilon power will become infinity. So 0, p less than 1, and infinity, p greater than 1. Then we can take this limit. Limit epsilon tends to 0. Epsilon tends to 0. 1 by 1 minus p, b minus a power 1 minus p minus epsilon power 1 minus p. Okay. So, p less than 1, this will become 0. In that case, p less than 1, this will become 0. In that case, this limit value become 1 by 1 minus p, b minus a power 1 minus p, this finite value. In the case of p greater than 1, this will become infinity. So, this limit value become infinity. So, we get p less than 1 have a finite value, and p greater than 1, it will become infinity. Therefore, we conclude that our improper integral is convergent. Improper integral is convergent if p less than 1, and it will divergent p greater than 1. Okay. So, we have p less than 1, we get a finite value. Limit value will become finite. And p greater than 1, limit value become infinity. So, we can conclude p less than 1, this value is convergent, and p greater than 1, this improper integral will divergent. Okay.